Hi, this is me Geek and I'm Dan. This is my CNC machine. It started life as an ooze nest ox, and then I completely kind of rebuilt it and just used parts and created this thing, which is just my CNC machine. The brain, however, is still the duet3d 2 Wi-Fi. I guess duet3d is the company name. It's the version 2 with Wi-Fi. It's a little bit older now, but I just updated it with the latest firmware, and I have been setting up something I've been wanting to set up for ages, which is proper probing and tool length setting and stuff to help manage the various complications of running a CNC machine. And we're going to run through it now. By the time I put this live, I will hopefully have a companion blog post that has some of the actual scripts and stuff in it for better reference. But let's talk about what the basic idea is. For this job, I want to carve text into the surface of this plywood. And whilst I do occasionally level the bed and all that sort of thing, plywood itself does not necessarily present a perfectly even surface. And when you're engraving text on a surface, you really want the depth of that cut to be even across the whole surface. So that's where various probes come in. This right here is my XYZ probe. It triggers as a binary thing if you knock it in any direction, including up. It's a little bit wonky because whilst I was setting this up, I broke things. I'll put a picture here somewhere of how badly that went. At some point I will update this probe, but for my purposes, I think we're probably fine. I really just want to get a basic position and a mesh. So let's talk about that. The concept here is that we use the probe to find the kind of XYZ 0 point of the workpiece, but then we also use it to define a grid of points all over it and have it just go and test them all, and it will check how they are relative to each other height-wise and build a height map. This basically comes from 3D printing technology. The software actually running on this machine is a RepRap software, and it actually mostly kind of thinks it is running a 3D printer, but there are various tweaks to it that allow you to do CNC stuff. There are some complications to trying to do this on a CNC machine that you don't have with a 3D printer. The main complication is that on a 3D printer, when you're doing mesh leveling, you're measuring the bed of the machine, and that's sort of baked into its understanding. Whereas what I want to do is probe the surface of a piece of material that could be an arbitrary height, and that does cause some issues, but I think we can work around them. So before we go any further, let's start with the beginning of this process. So, alright, so this is the web interface. You can kind of see it still says workbee up here because I started off with the stuff for the ooze nest machine and it's been upgraded at various points. This has actually never been a workbee machine, but whatever. I haven't bothered to change the host name. We're now running the latest version of the Duet software with the RepRap firmware. I've just done a homing sequence. Let me just close out these warnings from previous tests. And so you can see the machine position is X0, Y0, Z75. That is the top corner of my machine. That's great. I have the tool XYZ probe in it, so I have this macro calibrate XYZ probe. So we're going to run that bad boy. And the job of this macro is to drive us over to this hard point here. That's just any random fixed reference point. And the important thing is, previously I have measured exactly how high this surface is compared to where this triggers. Why is that important? Well, this is a probe and this is also a probe. So in my case, this is my K1 probe and this is my K0 probe. Now I can't probe this guy against this guy because they are both probes that want to trigger and they have a spring and they would trigger at potentially sort of inconsistent levels. So I need this guy to trigger on a fixed hard standing, but then because I have already measured exactly the offset between here and here, then it knows how much that offset is, and when it's calibrating its length, later when we measure a real tool against that, we can kind of figure out all that offset correctly. So the next operation we want to do is to just basically locate this virtual corner of this piece of plywood. It doesn't really matter in this case, like it's not super important. Let me bring us pretty close in. So I'll just get as close, so that's sort of roughly over the corner. And now I have another macro, which is called set work corner. And when I run this guy, we should probe onto the surface of the plywood, and then we're going to just come to the edges and measure where those are. If we were doing like proper machining, this would matter. The fact that this corner's a bit beat up would matter, but really I'm just using it as an overkill way to get me. The machine now has a set of working coordinates that are x and y, 0 over this corner and 0 is here. Now I say working coordinates, that's very important, because what we're about to do next happens in machine coordinates and not working coordinates. Okay, so back over here. So this is the macro we just ran, set work corner, and I will put all these on a blog somewhere. The next thing we want to do is run a mesh. So this is the bit that's actually going to do a probe. And the way this is set up is it's going to ask us how big is the piece of material we're working with. And in my case, this is basically, let's call it 520-ish wide. And the area I care about is about 200 tall. So my machine, the piece of plywood is bigger than that, but that's the sort of area that we're going to be machining in. So having told it this, it is going to calculate what the right spacing should be, because you can only mesh probe, I think it's like 400 points total. And whilst I think of it as I'm at work coordinate x0, y0, and I want to go x 500 and y 200, the actual command needs to know the machine coordinates, and this piece of macro is going to calculate that for me. So the first thing it's done is say it's configured my probe with a start height, which is machine coordinate 39.62 plus 10. So that's basically just saying that when I probe, it will think that it's going to start about 50 mil off the bottom of the machine base. And this is the thing that caused me to break a bunch of tool probes, because again, the mesh exists in machine space, not in work coordinate space, and those things are kind of important, specifically the Z height. So what I was having was initially I set the mesh thinking I was in work coordinates, and then it flew off in the wrong direction, and that broke things. But even once, so it now knows, I know to create the mesh that in the machine coordinates here, but it still thinks Z0 is like way down, way down. And what I need it to do is not crash the probe. And when you're doing probing, one of the configurations you give it is how high up to start from. So the last time I broke a probe, I thought I was good, but it was configured to start probing from like 5 mil above 0, which if you're a 3D printer and you're measuring tiny deviations, 5 mil above 0 is miles above 0. That's more than enough, and you don't want to waste a load of time coming all the way down from a long height. But in my case, where I am probing a sheet of 12 mil ply on top of the workbench, it meant that it just drove straight to 5 above, and that was well inside the workpiece, and it destroyed the probe. So the macro calculates where is the machine position, where have we just put our work coordinates, what is that offset, plus a safety margin. So it sets the tool probe height to start well above your material, so that when I start this next bit, it doesn't just immediately crash. And that was a key piece of revelation. So now that it's confirmed that detail, it then confirms, hey, I've calculated this mesh, and in machine coordinates, that's this set of things. It's going to use a 20 mil spacing. Am I okay with that? I'm going to say, yes, I am. And off it goes. So now this is relatively slow bit. It's going to sit there and probe away. Now, another thing that the macro does is I've defined a 15 mil margin to not probe, because obviously I have clamps on this and I don't want to hit the clamps with the probe. So this is now going to sit going back and forth. I'll put it on time lapse, but when we're done, we should have a bunch of data about exactly how flat this piece of work is compared to the workbench. All right, so now we've run that, we've completed, and we have this warning, and this is important because what this basically is saying is, I was expecting you to be probing a mesh of 0 against your workbench, and I'll be a little bit off, but this thing was like 39 to 40 mil off from 0, which is insane. But important thing, the deviation here is 0.312, so from minimum to maximum, we're only 0.3 of a mil off in height, which is not too bad, but is important enough, I think, to compensate for. Let's go upstairs. All right, so this is a slightly better way to show this web interface. I'm upstairs now, we've done our probing, we're looking at our height map, but what do we have? There's nothing here. What's gone wrong? Now, interestingly, it says over here, gives us the stats, says the maximum deviations of 39 and 40 millimeters, mean error of 39. Basically, it is telling me, oh, this is wildly off, but the actual error between points is pretty low. And the reason I can't see anything is actually if I scroll around to here, you can see all of those points are way up there off the bed, because it is designed to show me like tiny fractions of a millimeter differences at 0. It is not expecting me to have probed something wildly high above the bed. So what we're going to do now is we're going to fix the height map, because what I want it to think is that they are variations of its surface on which we have material, because otherwise, essentially, if I apply this height map right now, it will immediately tell me that my machine coordinates are in like -20, -30 or something, and that'll be outside my machine limits, and then it won't work, and that is a problem. Right, so let's go to system, we'll go to height map, and we will download the height map, and then I will go to my downloads. So download the height map, go fetch it from our downloads folder. Here it is. I'm going to drop it into my height map tool folder. I'm going to run this, and it is going to generate me a rebase version. So this is the first version that we generated this afternoon with this error of 39, min, max 40. All these points are at least 39 mil off the base, which is problematic. And now I have the rebased version where we've just recentered all of those deviations around 0. So if I get rid of that, save that like that, I'll just upload it as a rebased file. So if I upload a rebased, I'll override that thing. So now this is the rebased height map, which shows us, and you can see how exaggerated it makes the differences. This is for all of 0.312 deviation, but this shows us how not flat our plywood is. And now we've got it mapped into machine 0, we can use it without causing the machine to think that it's gone out of its limits. So next thing to do, swap our tool to a V-bit, apply, like get ourselves to 0, apply the height map, and hopefully we should be ready to cut some stuff and follow the contours of the plywood. Let's go do that. So let's take out our probe. So this probe is just a cheap, I got it from Alibaba possibly, or Banggood, one of those. I'll have to look it up. Basically just the USB-C plugs in at this end. On the Duet, it plugs into one of the various inputs. I'll go back and show you the code for the inputs, because obviously you need a different input for this probe and this probe. This is a digital probe, that's an analog probe. My Duet 2 only actually supports one analog input, so I had to put that one on that one, and this one could go on basically anything. This one I think goes, it is pretending to be like an extruder sensor something as far as this thing is concerned, but whatever. Right, so that comes out. Grab our nice sharp V-bit, stick that in instead, So now what we want to do is figure out where the tip of this is compared to where the tip of that sensor was. And that's where this guy comes in. So, too long. Okay, so that is an offset of 22.4 mil, which sort of sounds about right? If I hold these up together, they look like they're probably about an inch difference in height. So, now, if I come across, let's just come. So if I come down, all right. So now we've adjusted for the length of this tool versus the length of that tool. We still have our XY work coordinates correctly, but now we can also apply our height map. So if I do one, so this G29 command, give it the height map. Now if I'd just overwritten the original height map, the default is height map, and I might need to do that in the future, but this is specifically my rebased one. So if you see at the moment, it thinks that the Z height is 18 exactly, and we're just machine coordinates just off the bed. When I hit that command, this is adjusted up by 18.74, and now it thinks we're 1.5 mil above the bed. So what all of that should mean is that with this just above the bed, when we drive in either of these directions, X or Y, we should see the Z motor up here compensating ever so slightly for those differences. So let's see if we can show you that. So we're just going to say X plus 50, which shouldn't move the Z unless, I don't know if it's kind of difficult to tell considering it's moving as well. I'll try and give you a locked reference point. It's kind of tricky to see, but there you go. You can kind of see that it's twisting around. So it's adjusting that Z height, and as we can see, we are still nicely right on that surface. So I think that means we should be ready. I go give ourselves some clearance, and I plug in, actually start to fire things up. I upload. Then if I've done everything right, we should now carve nicely and maintain a good even level. Let's give it a go. Now what we should have is a nice even lettering all the way across, even though there's a little bit of tattiness just that needs to be sanded out, but hopefully we've got a very consistent depth of cut all across. So I promised I'd talk about exactly how the probes are connected. So this is my probe definition file. So K0, my tool touching probe. This is the tool touching probe. This is actually an analog signal. I guess because it kind of measures the distance of travel. I really only care about it as sensitivity as like on or off, but because it's an analog signal, the only input pin on the duet2 that takes an analog input is the Z probe in. So I put that one on the regular Z probe, and then I connected my XYZ thing that I mount in the spindle. This guy, he connects to E1 stop. So E1 stop is so E1 here has a bunch of, each one of these pins, basically you can provide a
I guess, an end stop signal. And I'm obviously using X, Y, and Z end stops already. And in fact, I'm using E0 to provide a second end stop for the Y axis, the gantry. But I had one left, so I have one wire going to the E1 stop, and it pulls power from the panel duo header because that USB-C XYZ probe requires 5 volts, which is not always the case for the whole machine. So you can kind of see this is the end of the USB cable that plugs into the XYZ probe. We've got the signal going into this end stop pin here, and this is actually I ran out of 3-pin connectors, so this is a 4-pin connector with one empty space in air, but effectively I'm just reusing this end stop signal, and the plus 5 and ground is coming from that panel duo plug-in header, and then these are the 3 pins of the regular Z probe, which then allows me to feed that analog. So that's the physical connections and how it is configured in the G code, and then everything else works. You just need to make sure that you are correctly referencing your K0 or your K1 probe for the different parts, which is what's in all the macros. So I will link in the comments below probably a blog post in which I'll share the various macros, and I'll put this chunk in there as well in case anyone happens to have a duet2 and wants to do the same little journey. It's pretty powerful, I think, once you get it working. I have managed to crash the probe a lot of times, but I've figured it all out. I'm pretty happy with it. Hopefully that's been interesting to somebody, at least. Thanks for watching. See you next time.